So this is the video for part 2 of slide set number 1. Here we're going to continue talking about the program structure, specifically going more in details about headers and header and source files, how to organize your includes, especially when you have redundant includes, as I will explain later, and also the notion of namespaces. So let me go here and get the slides. And always a good idea to load the newest version of the slides. I'm updating the slides often. Also because well, you might know sometimes you have to clear your browsing history if you want to make sure you have the right version. Okay, so let's sorry about that. Okay, so this is starting slide number 13, I believe. Okay, so here I'm going to talk a little bit more about header files and source files. You know, it's a little bit repetitive, but for this thing, I know from experience that it needs to be repeated. Some students, they somehow will not get it, and that's one of the most fundamental things that you should understand, even though, and that's what even makes it more possible that students will not do it properly, is that the compiler will not enforce that you do it as I'm explaining now. So the idea is that your header files or your .h files, so header file is a .h file, source file is a .cpp file. So your header files should contain the declarations of your classes, as well as the declaration of your free functions and your operator declarations. We'll see operators later. So, and if you have some member functions, then they should be declared inside of the class declaration. So the header file is providing you with a way to instruct the compiler to read or be aware of declarations that are defined inside of, declared inside of a component. It's also useful to programmers because what you really want to know when you want to use a certain component is you want to know what you can access from this component. What are the classes you can use from this component? What are the functions you can use either inside of the classes or free functions declared in this component? So that's what is the header file providing you with. What is it that you can use externally from this component? And the header file does not include the code, which if you want to use a component, you don't really need to know what is the code. All you need to know is what's the name of these classes and functions, which is all that is included in the header files. Then for a component, you need to define your CPP file or source file. Again, if you go to Visual Studio, you will see there's a folder for source files, folder for header files. Again, you could put your header files in the source file directory, but especially for Visual Studio, it's likely to create some problems. If you use GCC, then it's likely to create other kinds of problems. But anyway, so header files, source files. What the source files contain? They contain the function definitions, basically meaning that they provide the code for the implementation of the functions that were declared in the header file. So that can be free functions or member functions or any operator that you may have as members or free operators. And keep in mind, as I said in the previous video, CPP file or source file is a compilation unit. know more about that, go to the other video. General rules. That does not necessarily mean that these are enforced by the compiler. So these are more what people have a common understanding that should be done. First, there should be a one-to-one relationship between a given CPP file and a corresponding .h file. So generally speaking, you define a component. There should be a .h file and a .cpp file for this component. They should have the same prefix, the same file for the name for the file. The CPP file then hash includes its corresponding .h file. So if you go in the CPP file for a component, most often you will see hash include the name of the file .h. So basically, because the CPP file, the source file, contains only the definitions of these functions, which are members of the class, but there's no class declaration in the CPP file. Class declaration is in the header file. So in order for this source file to be compiled correctly, it needs to know what is the declaration of this class that these member functions belong to, for example. So that's why you have a component, you have a header file, CPP file. If you go to the CPP file, most often what you will see is hash include the name of this file .h. CPP file should never be hash included, as this is what it does actually is merging two compilation units together. The idea of a CPP file is that it is a compilation unit. If you go hash include, if you're in a certain CPP file and then you go hash include another CPP file, then what in fact is going to happen is that as you're compiling this file here, you will instruct the compiler to go read in this other file and include this code here. Thus, all the code that you have here is now suddenly part of this compilation unit. So you're effectively doing this, by doing this, you're taking the code of this other compilation unit and you're putting it here. So you're merging two compilation units. That's why you're allowed to do it, but you should not be doing this. This is not something that should be done. There are exceptions to that, as we will see later when you deal with templates and so on. That may be one of the solutions. Not to say that it's not possible or the compiler will say can't do that, but as a principle, that should not be done. Should never have anywhere hash include file name.cpp. So here is an example of a header file. Okay, so here that's a dtime.h file. So you see here that you have a class declaration. In this class declaration, you have the members of this class which are declared. So data members here, private member functions here, public member functions here. So here, and if you see, you have the function declaration, and then you have semicolon here. You don't have the implementation for this function comparatively to what you would need to have in Java. But basically what it means is that this class declaration here only includes member function declarations. So it just says, for example, in the class digital time, there's a function, for example, read hour, or let's take this one, digit to int, that takes a character and then returns an int, okay? So it does not say what this function is doing. So the assumption here is that if you would go to the CPP file that corresponds to this module, you will find the implementation of the digit to int function or member function. So that's what normally what a header file contains: class declarations for this module, and then some data members, member functions that are being declared in the class. Here, this example doesn't have it, but if you would have free functions declared in this module, then they would be here at the end after the class. It's possible also that a header file contains more than one class declaration, in which case they would just appear in a sequence. Let's go to the corresponding source file. Here, I'm not including all the code. Important to understand that. I'm just simplifying the example here. So this is my source file. This is my dtime.cpp file, essentially. Now here, what I have in my CPP file, as I said earlier, is a list of function definitions. Okay. So what are the functions that were declared inside of this header file or in this module? It's all these functions here that were declared as member functions of the class digital time. So if I go here, you see that I have a function definition for the class well, let's take this one. Let's come back to the other later. So here, this is a function named getHour. This is the implementation of a function named getHour, but this is a function getHour that belongs to the class digital time. So this : here is the scope resolution operator. So basically, you're saying here that this getHour function belongs to the scope digital time, which is digital time is a class. So basically here it's saying, this is here the definition of the member function getHour of the class digital time. Same thing goes here. If we go back to this one, of course, here I'm declaring a constructor for the class digital time because the name of the function and the class is the same, so that's a constructor. So here I'm providing with a function definition for one of the constructors of my class digital time. And here's the code for it. So for any function, either member function or free function, if I would have them, for any of them, I should have an implementation for this function inside of the source file. Again, as we will see later, it's possible that you would have the implementation of some of these functions here. It's possible, but we'll see that later. But in general, what you should have is only the class declaration, only the function declarations here. And then if you go to the CPP file, you would find the definition for any of the functions that have been declared in the .h file. And you see here that my file, my source file, dtime.cpp, it first, well, it does other things before, but here it basically hash includes dtime.h. Why is it so? Because when the compiler compiles, you tell it to compile the CPP files. So if it will eventually compile this CPP file here, and then if it does, and you don't have this here, then it would see digital time. There's no such thing as digital time that has already been declared. So basically it will tell you digital time is an undefined type or class. So that's why, and because the class digital time has been declared inside dtime.h. So if you want to be able to use the type or class digital time, you must previously hash include dtime.h, which includes the declaration of the class digital time, so that when you come here, compiler knows at this point in time what is digital time. That's why when you have a CPP file, generally speaking, it should always start with hash include the .h file of this component. So this is another sum up here. Typically for each component, there's a component X, there is a x.cpp and a x.h file. So that's a file duo that always comes together. Any source file generally hash includes their own header file. Generally, because it might happen sometimes that you have a CPP file that, for example, a CPP file that does not use any classes, or anyway, just say that it may happen that you would have a CPP file that does not have a corresponding header file. For example, if you define a driver, say, that contains only your main function, this module, this CPP file contains only the main function, and it does not need to have a header file. That's just one example. Any source file x.cpp that uses entities defined in another component should start with #include other component.h. So if a component uses the entities declared into another component, it should #include its header file. #including your own header file is a specialized example of that. As you define your own code as the component, you must #include the declarations of the things that are declared inside of your own component. So this way, when you compile x.cpp, and it starts by having #include this other component, the compiler reads what is included there, becomes aware of the classes and functions and member functions that are declared there, so that when you compile your own x.cpp code, then it's aware of what was in this, what is declared in this other component. Another variation of what I'm saying here is that any file that refers to some names not declared internally in the file must #include the file that declares these things that you want to use. If a function definition is compiled contains a function call for a function that was properly declared, this function call needs to be resolved. So this is where the linking or the resolution of the linkage between a function call and the code of a function comes into importance here. So if in the CPP file you're calling a certain function, if this function is actually declared and defined inside of this compilation unit, then the compiler will be able to find it and then make the linkage properly if it's declared and defined in this compilation unit. However, if a CPP file is calling a function that is declared and defined in another component, then all that the compiler is going to be aware of is the declaration of this function. It's only going to know that there should exist a function of this name as it read it inside of the header file. Keep in mind, the header file does not provide the implementation, so it cannot link with the code. It only knows that this function exists by having encountered its declaration. So that's why, and the code can be branched upon when you execute this function is only compiled when you compile this specific CPP file. So if the function is defined in another compilation unit, then the linker needs to be coming to effect after that will resolve this this calling of a function across two different object files. So you guys know about Java. So this is essentially the same concept that's happening in Java. However, in Java, it makes your life much more easy from the fact that for every class that you have a one-to-one correspondence between a class and a file. Okay, so that makes things much easier to resolve. However, because in C++ you can have inside of a component, you can have as many classes and functions as you want, that makes things a little bit more complicated. That's not to say that Java does not do the same. There is linkage and so on and so forth, but it's conceptually more easy because of the fact that you have a one-to-one relationship between classes and files. And that's a very good example of the fact that C++ provide you here with much more flexibility. It allows you to have more than one class for each file, but it also makes things more complicated to use. So yes, it opens the door for many more possibilities for you to organize things as you want, but also this freedom comes with a cost. That's one of the fundamental natures of C++, especially versus Java. So header file inclusions. So that's what I was telling you here. I'm going to talk about inclusions in more detail. So that the header file contains an entity, the components entities declarations. So that's the classes and the free functions and the member functions are all declared in the header file. So it should always be the case that if you have a class declaration, it should, in most cases, be that your class declarations are in your header file. If you see code, code in a source file, a CPP file, it has a class declaration, it should be an exception. There should be a very good reason for it, or else this is bad design, okay? Always when you see a class declaration in a CPP file, you may take for as the first reaction should be, oh, this is very bad design. Maybe there's a reason for it, but try to not invent too many reasons for doing it, okay? As a rule, if you see a class declaration in a CPP file, very likely it is that it's bad design. So that's basically the header file defines what are the things that are available to the exterior from this component. If you want to use this component, all you have to be aware of is what's in the header file. That's why you hash include this header file. So there's two different syntax if you want to use a component through its header file. So you can go hash include and then double quotes, the name of the header file. So that's basically saying here, this is your own user-defined header file, and the compiler, when it sees the double quotes, it will look inside of your project and try to find this header file. On Visual C++, it's going to look into the headers folder. If you go hash include and use angle brackets like this, then it's basically indicative that this is a system library. Okay, so depending on what libraries that you have installed in different folders here and there, then the compiler, if you use angle brackets, is going to look into these folders. Okay. So depending on how you install these libraries, during the installation process, you will tell the installer to install in specific folders. If you don't, then you would need to set the path accordingly, the search path for the compiler accordingly. Generally, you try to avoid that, and we'll not deal with that in the course, but that might become a problem if you install in custom folders, for example. So source files. So that was about header file previously here. Source files, components implementation code should always be in a CPP file. If you see some implementation code for a specific function, for a function inside of a header file, there should be a reason for it. You don't by default provide the implementation of your functions inside of a header file. You can do it, but if you do, there should be a reason for it. We'll see later on what are the reasons for it. But I would say valid reasons for it. So in the end, when you define a certain module, let's say named my module, you should have both a mymodule.h and mymodule.cpp file. Now that's what should be. the compiler will not enforce that, will not say, oh, you have a CPP, mymodule.cpp file, but you don't have a mymodule.h. No, compiler will not check that, okay? That's up to you to make sure that this is the case, okay? If you could name your files mymodule.cpp and then blah, blah, blah.h. And then in mymodule.cpp, you go hash include blah, blah, blah.h. You could do that, but that makes things confusing because now if you want to use the entities defined in this module, then which is named my module, then you should go hash include blah, blah, blah.h, not same name, confusing. That's why they should both have the same name. Again, not enforced by the compiler. The component is composed of classes and free functions. If you have member functions, they are declared inside of the class declaration. When you have a source file, first thing you should do is hash include the header file of this module. If you don't hash include the header file of this module, then when the compiler is going to try to compile the function definitions, then inevitably it's going to come onto the type name of a class declared inside of this module, which should have been defined in the header file. If you did not include the header file on top, it's going to complain that this name is undeclared. So, and then your CPP file should contain the executable code of your functions or the function definitions. So what are your function definitions? You can have, well, first, the main function is a function, so it should always be in a CPP file. If you have classes in this module, you should have member functions. They should be defined in the CPP file. If you have free functions inside of this module, they should be defined in the CPP file, and you should have a function declaration in the .h file. If you have operators, either free operators or member operators, they should be defined in the CPP file, declared in the .h file. So, CPP file contains function definitions, and their declaration is actually found inside of the header file. Now, what I kept on saying is that one of the things I said is that you should hash include your header files. Now, the thing is that here we're talking about a component that uses or wants to use another component. Now, it's possible that as you compile all your compilation units, that eventually more than one component actually or as you're compiling one component, it's eventually going to try to hash include the same header file more than once, okay? So for example, it's possible you have a file here, a CPP file, and it goes, for example, hash include a certain file name, which is this .h file here. Right? So, but it's possible that on top of this file here, you have hash include another file, hash including this file here. But it's also possible that in this CPP file directly here, that you are using these entities here. So you will go hash include this file name here. Okay, so as you compile this here, the compiler is going to see hash include this, so it's going to read this code here. Then it's going to continue here, and then it's going to want to read this code here again, which is going to tell, the compiler is going to tell you, well, these things are being redefined, okay? So it's possible that as you are reading these files, that eventually you would be actually wanting to, as you compile a single compilation unit, that it would direct you somehow in reading twice or more than once the same file that contains declarations. So if you read twice the same declaration, it's a redeclaration. The compiler will say, well, you know, this class here, I already read it before. This is a redeclaration of two things which are of the same name. It will not know that this is actually the same thing. So these are called redundant includes. So header files are typically included multiple times in an application, because when you define this component here, the idea of defining a component is that this component can be used in a lot of different places. If it is used in a lot of different places inside of the same compilation unit, then reading its header file is going to lead to have redeclarations. So basically, the thing is that you should find a way so that when you already read this header file here, that it is not read more than once. Okay. So the solution to this is to use what is called preprocessor directives. Okay. Fact of the matter is that anytime you see hash in the beginning of a C++ a line of code, this is actually not C++ code. This is C++ preprocessor code. Preprocessor is a component that comes into effect before the compiler. One of its goals is, for example, to assemble all the code that pertains to a single compilation unit and then feed this whole code to the compiler. So that, for example, if you compile this, then the preprocessor is going to see hash include this. So it's going to basically take the content. So that's the whole file that it's going to send to the compiler. So it reads, the compiler reads this here, sees this. So the preprocessor takes the content of this file, copies it here. Then there's a hash include this here. So it takes the content of this file here, copies it here. Then goes back to here and then hash include this. It would take the content of this file and copy it again here. Thus you would have a read declaration. Then it would copy this code here, here. And that's this code here that is sent to the compiler. So that's one of the jobs of the preprocessor. And these hash lines are directives for the preprocessor to do this job. So there's a preprocessor directive that you can use to prevent multiple or redundant includes. So one of them is to use a hash if not defined and hash define. Essentially, it's used, let's start with hash define. Hash define, so you basically declare a variable that is used by the preprocessor. Here, the variable name is fname_h. So the assumption is here that the name of this header file is fname.h. The convention is that you say that the name of the variable that is used for avoiding redundant includes is the name of the file, but in capitals and with an underscore here. That's a convention that we use. If you don't use exactly this name, it's going to work anyway, but the convention is to use the same name, but in capital letters. So essentially here this says, it instructs the preprocessor to define this variable. It does not provide a value for this variable. All it does is that it defines the existence of this variable. So the preprocessor will now have some kind of dictionary of variables that have been defined, including this one here. Now, here, if and def, fname_h says, if fname_h has not been defined, then you do this here, okay? So first time around comes here. If fname_h has not been defined, which is correct because let's say it's the first time it's executed, then first thing you do is to define fname_h, then compile this code. Then the second time around when it comes back, if fname_h is not defined, then this is false, it has been defined. So the second time around, you don't even enter here and you basically skip all this code here, okay? So basically it makes it so that you ever only, if a header file contains this structure, having these two lines at the beginning and this line here at the bottom, it will ever be included only once by the preprocessor. Another thing that you can do is to use a more advanced preprocessor directive, which is called hash pragma once. If your header file starts with hash pragma once, there's a mechanism inside of the preprocessor that will make it being include only once. I absolutely agree that this is more easy to understand. Why did I explain that to you here? Because if you see legacy code, you will see this all over the place. So it's important to know how it works, okay? But nowadays, most people use hash pragma once, but you will see that all over the place too. So this is a variation or specialization, I might say, of if-def and if-and-def, if defined or if not defined. So the idea of if-def and if-and-def is to do what is called conditional compilation. So for example, if you have hash if-def x, then if the variable x has been defined, then you would compile this. And if it's not defined, then you would compile that. Okay. So depending on if the variable has been declared, the pre-compiler or preprocessor, a variable x has been declared before, you would either compile this code or this code. So this allows you to turn on some flags to enable some code or disable some code depending on the situation you want when you compile the application, the behavior that you want, variable behavior that you want from your code to execute. That's basically a conditional compilation, which this is a specific, very often used specific use. Let's go to namespaces. So jumping a little bit here and there, but namespaces is also has to do with the structure of programs. You don't need to have namespaces, but again, this is something you will encounter very often. So when you define your own C++ programs, you don't need to define your own namespaces. Okay. The only reason I'm explaining it is, well, sometimes it's useful, but you don't need to have them. The reason why I'm explaining them is that you have to deal with them very often. You may have seen in some of my previous examples that very often a CPP file will start with hash include IO stream using namespace standard. So this would be typically when you want to use a cout or cin object that we will talk about in lecture number 3. These are basically streams that you use to interact either with the console or the keyboard. There's other streams such as file streams and so on that are also defined in the library IO stream. Basically here you're hash including the library IO stream if you want to use this component, which is defined as a library. But what is the meaning of using namespace standard? So what is a namespace? Namespace is essentially a collection of names that are defined inside of a component. The idea being that when you define a component, you can define different namespaces in it. So you define this component here. It has a list of entities that are part of this component. Now, what you may want to do is to partition these components into groups. Okay. Then you might say, well, this is one of the groups, and this is another group here. Okay, so you're basically partitioning your entities inside of your component. Okay, that's the notion of a namespace, and essentially you give names to them. Let's say NS1, NS2, or you might want to create another one as is using namespace standard. You name this one STD. Okay. Essentially, what that means is when you go hash include IOStream using namespace STD, if you go in the code of IOStream library, you will see a namespace that has been named STD. And when you specify this here, you specify that you are using from this library, you are using the things that are declared inside the namespace STD. If you would not go using namespace STD, then you would, for example, the cin and cout would be declared here. If you don't go using namespace STD, then these would be invisible to you. Okay. So you turn on or off some of the namespaces that you want to use. So if you go using namespace STD, then that basically includes all of the things that are listed inside of this namespace. You may also want to use only specific ones that are being declared inside by using using a specific names. So if you want to use only cin and cout, then you might go hash include IOStream using std : cin, std : cout. Again, : here is scope resolution, but here where the scope is a namespace. That's basically saying using cin that is declared inside of this std namespace. Okay, so namespace is a scope as much as a class is a scope. So that's why the scope resolution operator applies to both of them. So that's why, explaining why you very often see these lines here, but you could also use something like this. Here, that makes it so that you are potentially including all kinds, because if you go in the IOStream library and you look in STD namespace, you'll see a lot of different things. So potentially if you go using namespace STD, the compiler is going to read all of these things here. Okay, likely to make your compilation longer if you're doing this here. Well, all C++ compilers are very much optimized, so it's possible that it's going to figure out which ones you are using anyway. But here it's more general, and here it's much more specific. So for example, as you as a programmer, when you read this code here, you know exactly what this file is going to use. Whereas if you read this on top of the file, you don't know what this code is going to use. It's good indication also for your fellow programmers that are going to read your code. Makes your code more readable or understandable. So namespaces are essentially named for preventing name clashes. But it's possible, for example, that in this component here, you have a function f that is defined. Let's say in NS1 and in NS2 too. Okay. So it's possible that in this component, there are two things you want to name f. Okay. For some reason, sometimes you want to use this f and sometimes you want to use this f. You want to have two different meanings for a function f, which you turn on sometime, this f, and sometimes you turn on this one. If you want to turn on this f, then you would go NS1 : f, or using namespace NS1. If you want to use this one, you go using namespace NS2 or NS2 : f. Okay. So sometimes you have two things which are named the same in the same component, and you want to switch between them from time to time. The fact of the matter is that these are two things which have the same name. You want to have both, but be able to switch from time to time. If you would have two things that are of the same and you don't have namespaces, then the compiler would complain here that f has already been declared, right? Okay. So that's essentially what I was exemplifying here on the board. Except here, oh yes, so here I'm saying that when you use using namespace, it is actually the effect of the using namespace is local to a code block. So imagine that you have in a function implementation, you would have two code blocks like this that are that are written consecutively like this, for example. So when you have using namespace ns1 here and you call my function, this using namespace ns1 is local to this code block here. When you get out of this code block, then the code does not know anymore that it was using namespace ns1. But when you go to this other code block here and you go using namespace ns2 and call my function, it's now my function of ns2. Okay, so using namespace is local to a code block. Same thing can go for using the colon operator, as I mentioned earlier in my example on the board. So there are different kinds of namespaces. There is what is called the global namespace. So I guess you all know what is the meaning of a global variable. If you declare a variable outside of any curly brackets, basically outside of any scope, it is, the meaning of this is that this is a global variable, okay? So that's what is called in C++ parlance, this is called the global namespace. And this is basically, the assumption is that there is this global namespace, but this is not a namespace that you need to declare. You don't need to say namespace global. It's by default, if you write something that is outside of any scope, it is declared inside of the global namespace. Of course, then there's no way that you can switch between global namespace because it does not have a name, okay? So how do you create a namespace? So essentially, a namespace is a block. It's a code block. So you need to have the open and close curly bracket to specify what is the beginning and what is the end of this namespace. And then before this code block, you go namespace and then whatever name you want to give it. Okay, that essentially names this code block here space1. And that's now a namespace whose name is space1. Then you can actually, after that is done, and the compiler has read it, if you go using namespace space1, then it would somehow activate this namespace. So inside, so inside of this, these open and close curly brackets, you would define some entities. So when you turn on this namespace by using namespace space1, that would make these entities here to be available for usage. If, for example, if inside of this code block here or this namespace, you would define a namespace named NS entity, another way to actually use this NS entity, well, you could enable the whole namespace, but you could also go using space1 : NS entity. Now that raises the question: is what if I'm declaring a namespace in a header file? What happens to my CPP file? So if I declare that in my module, in my header file, there are some class, for example, that is part of namespace X, then when I have my corresponding CPP file, then I should also refer to namespace X to contain the elements that are declared as being in namespace X. So yes, there has to be, if you have a namespace being used in your header file, it should, in most cases, have a the same corresponding namespace being declared in your CPP file. Okay. So for example, if you in your header file, you declare a function, a free function named greeting. Then if you go in the corresponding source file or implementation file, you should see this greeting function being defined, that is defined as part of a namespace, the same namespace as it was declared in the header file. So, then when you have, oh yes, so here that's another use of the colon operator. So if you want to refer to a specific element that is declared inside of a specific namespace, you can actually use inline in your code the colon operator to actually point to this element that is being declared inside of a namespace. For example, if you want to use the iStream class name that is defined inside of the IOStream library, then you can go hash include IOStream, and then you don't use using namespace standard, but here you would go std : iStream. So that would basically say iStream is an entity that is defined inside of the namespace std. So here you're not using a directive, you're essentially using inline, you're using the scope resolution operator to do the same. Here's an example. I'm going to go quickly over this. I already explained. So if in your header file here, you have a class being declared, and then this is a namespace that contains this class declaration, then if you go, and then of course, this class would have some members, potentially some member functions that are declared inside of the class. So if you go in the corresponding source file, then you would have the definition for these member functions that are declared inside of the class name here. But these are declared inside of the namespace d times savage. So their implementation should also be declared in the namespace, the same namespace. Okay, so when you declare a namespace in either of the CPP or .h file, most often you have to have a kind of a mirror image. There's a namespace in the header file. Normally there should be the same namespace in the CPP file. Another particularity, another specific kind of namespace is what is called the unnamed namespace. That would be a namespace that you declare. So you open a block, close a block, and then you have namespace before. Except in this case, you don't give a name for it. You just go namespace. Open curly bracket, some code, close curly bracket. It's unnamed namespace. So the particularity of the unnamed namespace is that it's like the global namespace, except that it defines a namespace that is global, but only to the current compilation unit. That means whatever you declare inside of this unnamed namespace are global variables as far as this compilation unit is concerned, but they cannot be referred to from outside of this compilation unit. Okay. So that it's important to understand that it appears to say that these are global variables. There's a difference between a global variable and a global variable defined, declared in the unnamed namespace. A global variable is declared outside of any namespace and is available, yes, inside this compilation unit, but also potentially from other compilation units externally. If you declare something in the unnamed namespace, yes, it is a global variable internally, but it is not ever available from the outside. Here's an example among many others. You will find in the lab examples, other examples about this. This is one of them. So here, yeah, I'm declaring a variable here, I, in the global namespace. You see this I here is not declared inside of any curly brackets. So it's a global variable declared in the global namespace. Here, I'm declaring this variable also named I, but in a namespace which does not have a name. So that's the unnamed namespace for this particular compilation unit. So the fact of the matter is that here, if I try to print to the console, to output to the console the value of I, and when the compiler compiles this, it will see that there's this I, which is global, and this I, which is also global from the perspective of this compilation unit. So the compiler would say variable I is ambiguous. So all this to say that these are, from the perspective of this compilation unit, this I and this I are two global variables. If you would try to refer from the exterior the variable I in another component, then this one would be invisible. But this one would potentially be visible. Okay, so that's about it for this one.